Why do we find ourselves constantly yearning for more bandwidth? The answer lies in our ever-increasing demand for data. As technology advances, so does our need for faster and more reliable data transmission. However, the capacity of our current telecommunications networks can only stretch so far. Enter wavelength division multiplexing, or WDM. WDM is a game-changing technology that allows multiple signals to be transmitted over a single optical fiber by using different wavelengths of light. It's akin to adding more lanes to a highway, but instead of physical lanes, we utilize different wavelengths of light. This innovative approach significantly increases the capacity of optical fiber networks, making it a vital solution to our bandwidth woes. But how exactly does WDM work? Simply put, WDM combines multiple signals onto a single fiber by using different wavelengths or colors of light. Each signal is carried on its own unique wavelength, ensuring they don't interfere with each other. This allows for a tremendous increase in the amount of data that can be transmitted over a single fiber, thereby expanding the capacity of our networks. The beauty of WDM doesn't stop at capacity increase. By enabling multiple signals on a single fiber, it reduces the need for more physical fibers. This in turn lowers the cost of network infrastructure, offering significant financial savings. Furthermore, WDM enhances network reliability. Should one signal fail, others on the same fiber remain unaffected, ensuring uninterrupted data transmission. In today's digital age, WDM has found its place in numerous applications. From long-haul telecommunications networks carrying vast amounts of data over great distances, to metropolitan area networks transporting data within cities, WDM's presence is undeniable. It extends its reach into data centers, connecting servers and storage devices, and even finds application in wireless technologies like freewave and Li-Fi. In conclusion, WDM is not just a solution, but an essential technology for meeting our growing bandwidth needs. As our demand for data continues to rise, so will the importance of WDM in our telecommunications networks. It's no longer a question of if we need WDM, but rather when and where we apply it. And so as we navigate this data-driven world, we can rest assured that WDM will be there, lighting the way to greater bandwidth and beyond. Despite the numerous advantages and applications of wavelength division multiplexing that we've discussed, there are indeed scenarios where WDM may not be necessary. In contexts where the demand for bandwidth is relatively low, a single wavelength of light can suffice to transmit all the required data. For instance, home networks and small business networks often do not need the immense bandwidth that WDM provides. Similarly, metropolitan area networks, or MANs, which are networks that cover a larger area than a local area network but smaller than a wide area network, may not always require WDM. Backhaul networks, which connect core networks and edge networks, may also not need the high bandwidth offered by WDM. In essence, while WDM is a powerful tool, it's not always the most cost-effective solution. The equipment and infrastructure for WDM can be expensive, and it's only worth investing if the benefits of high bandwidth are truly needed. Always evaluate your specific needs and circumstances before deciding whether WDM is the right choice for your network. Moving on, let's delve into why dense wavelength division multiplexing, or DWDM, is crucial for telecommunications, or telco, particularly for long-haul and metropolitan area networks. DWDM, a type of WDM that uses more tightly spaced wavelengths, has the potential to significantly augment the capacity of a network. This is vital in an era where bandwidth demand is continually on the rise. Moreover, DWDM enhances the reliability of a network. In the event of a signal failure, the rest of the signals on the same fiber remain unaffected, ensuring smooth and uninterrupted transmission of data. Another notable advantage of DWDM lies in its potential to reduce the costs associated with telecommunications networks. By using DWDM, the number of fibers that need to be deployed can be minimized, resulting in substantial cost savings. In conclusion, as we march towards a future where the demand for data is skyrocketing, DWDM is set to play an increasingly important role in telco. It's not just about addressing the growing need for bandwidth, but also about ensuring that telecommunications networks remain dependable and cost-effective.